Hi, my name is Santini. My number AP210334. I want to introduce SLA. SLA, or Stereolithography, is a very used 3D printing process and the most popular of the recent printing technology. The process is simply in the activities way or its ability to produce prototypes that are accurate, isopropyl, and water, as well as production with impressive surface, smoothly, and more detailed features. SLA is an additive manufacturing process that belongs to the polymerization family. The technology are used a light resource to curb polymerasis. Stereolithography SLA uses UV laser as a light result to scientific crowd of polymerization. Last week we are going to resist the adaptation and we argued about the 3D printing. I will show the picture as below. Let us go to see the review. SLA 3D printing.
The Form 1 Plus lets us take advantage of a library of materials, so we made some other parts to show what these resins can do. A castable resin gives jewelers and engineers an inexpensive way to produce metal parts. This flexible resin is great for simulating different textures, and as we can see, this tough resin can really take a hit. Now let's compare how the Form 1 Plus parts stand up against a filament printer. The stereolithography part comes out nice and smooth, but we can see and feel the ridges on the cup printed with filament. When we break this sample piece, you can see that filament parts quickly snap along the layer lines. The SLA process creates a chemical bond, so our prints take much more force. Today, we took a look at how stereolithography printers work, the types of resins they can print with, and what makes the parts stand out against other desktop machines. If you liked our intro to stereolithography 3D printing, check out some of our other videos.
This is the technology for you. But this technology is not known for producing parts with high strength. Stick around to find out why. Hello people of the internet, and welcome back to the next episode of What is 3D Printing? My name's Ben Redwood, and this week we're going to be talking about SLA, the original 3D printing technology. So as fun as it is to destroy parts, we should probably learn how they're also made. SLA is part of the vat polymerization category. So why the name vat polymerization? Well, the technology utilizes a vat, as well as lasers to cure photopolymer resin, the polymerization process. To produce parts, vat polymerization follows four main steps. Firstly, the build plate is positioned inside a tank of photopolymer resin. The build platform is positioned so that a very thin layer of resin covers the surface. A UV light source then scans the first layer of the part. Because photopolymers are sensitive to ultraviolet light, the resin is photochemically solidified. With vat polymerization technology, the average layer height is about 100 microns, but they can go as low as 25 microns, much smaller than FDM. When a layer is finished, the platform moves down one layer height, and a sweeper blade recoats the cured surface with a layer of uncured resin. The light source then solidifies this new layer, and the process is repeated, slowly building the part up one layer at a time. Finally, after printing, the part is still not fully cured. If you're after the optimal mechanical properties for your part, you need to take it away for some post-processing under a UV light. But if you're not in a rush, you can put your parts in front of an open window and good old Mother Nature will do the job for you. Like I mentioned earlier, the two most common forms of vat polymerization are stereolithography, SLA. Most indistinguishable, I'm going to use the term SLA for the rest of this video just to make things easier. So what are the important things to consider when trying to decide if SLA is the best 3D printing technology to produce your parts? After support removal and some post-processing, SLA parts have a very smooth surface, making the technology ideal for injection mold prototyping or visual models. Because of the small laser spot size and small layer height, SLA is perfect for designs that have fine, intricate details, as well as parts